Today we will study the topic of rational and irrational numbers. This topic you have studied in class 8 and we will develop it further to optimum level in class 9. Okay. Now if you take any real number, real numbers are denoted by R. They are classified broadly into rational. So the short form is Q, it's a standard short form, and irrational. Rational and irrational. So Q, and we call it Q dash or we call it Q bar. Whatever you are comfortable with, you can use the notation. But R stands for real numbers. Okay. Now any number you take at this stage, it will be a real number. Like say 2.3, 7.3939 recurring, or 2.384 ... neither terminating nor recurring. So any number you take will be a real number, except, okay, even you can take say square root of 2, that is also a real number, except numbers like something very offbeat, square root of -9. This cannot be a real number. Let us see why. If you say square root of -9 is 3, that is not correct because 3 square is 9. We want -9. So then we would say, okay, square root of -9 can be taken as -3. That is also incorrect because -3 the whole square again is 9 and not -9. So how do we find square root of -9? Now square root of -9 will be 3i, 3 small I. All these things now go in the category of imaginary numbers, which you will study in class 11. But otherwise any number you take, okay, you will have, it will be a real number, and real numbers are broadly classified into rational, Q, and irrational, we call them as Q dash or Q bar. That's a short form, like N stands for natural numbers. Let us see what are rational numbers. Easier way to understand would be any number you take either terminating or recurring. Either terminating or recurring numbers will be rational. We'll take some good examples. Irrational numbers would be the negation of this. Neither terminating nor recurring. Neither terminating nor recurring. Okay, so rational numbers are either terminating or recurring. Irrational would be neither terminating nor recurring. A number which is rational cannot be irrational, and vice versa. There is nothing common between rational and irrational numbers. Okay. So Q union Q dash. Set of rational numbers, you unite with set of irrational numbers, they will give you set of real numbers. And set of rational numbers intersection with Q dash. What is common between rational and irrational? Nothing. A number which is rational cannot be irrational. So there is nothing common. So it's a null set phi, or we write like this. But this phi cannot come inside this, then the whole meaning changes. So we write this as a null set. There is nothing common. This you are okay? Now let us see some examples of rational numbers and of irrational numbers. See, here we have said either terminating or recurring. So 0 is a rational number. It is terminating. 11 by 3. It's a fraction. 11 by 3 fraction. This is also a rational number because you take any fraction, okay, either it will terminate, like say for example 5 divided by 2, 5 by 2 is a fraction, 2.5. Either a fraction will terminate or it will recur. Like something 11 divided by 3, you just actually divide and see, it will recur. 22 upon 7. Do this, you will get 3.14285 something, and then after few digits a pattern will start recurring. Okay, we can even have -1. This is terminating. Then something like 10.341341 ... This also would be rational number. Okay, because 341 and then ... That means this pattern is now recurring because we have already written it twice and then we have put ... So this becomes a category of recurring. So these are all examples of rational numbers. Square root of 9. Square root of 9 is how much? Plus or minus 3. So no problem, it is terminating. So this also would be a rational number. Okay, and all fractions will be rational numbers. Remember like that. Provided the numerator and denominator can be expressed as integers. I mean, what I am trying to say is, now root 3 upon 2 cannot be a rational number because the numerator is itself irrational. We will come to this a little later. Let's come here. Neither terminating nor recurring. Neither terminating nor recurring. Say for example 7.214 ... This is irrational because it is 7.214. After that what comes we do not know. There is no pattern which is recurring. Okay, and neither it is terminating because it is ... So 7.214 ... will be what? Irrational because it is neither terminating nor recurring. But 7.214 and then if we put ... this would be clearly rational because a pattern is recurring. 7.214 and then ... Here it is open-ended. It is 7.214 ... After that what comes we do not know. So it is neither terminating nor recurring. Therefore it is irrational. Okay, even if we have something like 7.2141 and then ... this also will be irrational because see 7.2141, okay, the digits so will come again, but a pattern should recur. So this again will be irrational number. Then square root of 2, square root of 3, cube root of 9, all these are irrational numbers. So remember, all square roots and all cube roots, all square roots and all cube roots would be irrational numbers except the square root of perfect squares, like square root of 16, that is 4, so then that is terminating, so it is rational. Cube root of 125, that is 5, that is again terminating, so it is rational, no problem. But something like cube root of 9, square root of 2, square root of 3, all these things would be irrational because if you try to find it out, the square root of 2, okay, on a computer program, it will neither terminate nor recur. So square root of 2, square root of 3, cube root of 9, then pi, these are all irrational numbers. Now here you may have little query. You are under the impression that pi is equaling 22 upon 7. You have used it so many times. So if 22 upon 7 is a fraction, simple fraction, and I have classified that as rational, then how can we say pi is irrational? Because pi is equaling 22 upon 7. Now actually pi concept wise is different. 22 upon 7 is like a normal fraction, how you have 21 by 7, 11 by 7, 7 by 11. So similarly 22 upon 7 is a simple fraction Okay, and if you do 22 divided by 7, do it in your notebook. After certain number of digits, it will start recurring. It will be 3.142 and something. So 22 upon 7 is a fraction and it is a rational number. No problem, because it recurs. Whether it recurs early or whether it recurs after a long time, that doesn't make a difference. Pi conceptually is very different from 22 upon 7, as you know. It's a ratio of circumference to the diameter of the circle. So conceptually pi is very different. And inherently a value of pi has been found out. Okay, inherently pi is irrational because it neither terminates nor recurs. And computer scientists and mathematicians have found the value of pi to some trillion digits so far using very advanced algorithms and supercomputers. So pi inherently is irrational because it neither terminates nor recurs. Then why do we say pi is equaling 22 upon 7? See, it is like, I can draw an analogy. It is like a celebrity and his or her look-alike. Both of them are very different person, but only looks wise they are the same to some extent. Something similar can be said about pi and 22 upon 7. Pi ka actual value, if you go to see, is 3.141 and it goes on. It neither terminates nor recurs. Whereas 22 upon 7, if you actually perform this division, it will be 3.142 and another 2-3 digits will come and then the pattern will start recurring. You do it. Take it up to 10 to 12 decimal places, some pattern will start recurring. Okay, this 3.142 and so on, and this set of digits will recur after some time. The same thing does not happen in pi. So please remember, pi is irrational, whereas 22 upon 7 is a normal fraction and it is going to recur. So it will be, this is rational. However, as you observe, up to 2 decimal places, their values are same, coincidentally, up to 2 decimal places. And for real life calculations, 2 decimal places are sufficient. So whenever we have pi, instead of taking 3.141 and so on, we say, okay, let's take pi as 22 upon 7. It is only for the sake of calculation convenience. Inherently, intrinsically, pi has conceptually very different and 22 upon 7 is something very different. It is just that their values match only up to 2 decimal places. So we say, oh, pi is equaling 22 upon 7. So now we know that pi is different concept, 22 upon 7 is different concepts. Okay, they are, it's like, you know, imagine both of them are in 2 different planes. Okay, so pi will be irrational and 22 upon 7 would be rational. Okay, so this is done. Now coming back to this, here I was telling you, there is one more way in which you can understand rational numbers. Okay, any number which can be expressed in the form of a fraction, p by q, any fraction, where numerator and denominator both can be expressed as integers. Okay, example now 2.5 divided by 3.3. This can be expressed as a fraction. It will be 25 upon 33 nicely. So this will be a rational number. That is other way of looking at rational numbers. But I feel this definition would be little easier for most of the students. Now, I had told you all fractions are rational numbers. Yes, but then you can't have fractions like this. Root 3 by 2. Okay, this is a numerator, this is a denominator. What it would be? Here the numerator cannot be expressed as an integer. Like root 3 value is what? 1.732 and so on. Neither it terminates nor it recurs. So root 3 is irrational. Okay, so naturally root 3 divided by 2 also will be irrational, because when root 3, if you try to find it out on a computer, it neither terminates nor recurs. It will be 1.732 dot 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 blah blah blah, it will go on. A pattern will never recur only, and nor will it terminate. So if upper number is not terminating, then when I divide such a number by 2, that answer also will neither be terminating nor be recurring. So then root 3 by 2 will definitely be irrational. So this would be irrational. However, if you take something, a proper fraction, like where numerator and denominators can be expressed as integers, even if they are not integers, no problem, they can be expressed as integers by some technique, then such a number would also be known as a rational number. However, root 3 by 2 will be irrational. What would be root 7 the whole square? Rational or irrational? Rational. Now, at the outset you may feel, oh, root 7 is irrational, fine, but root 7 is not asked. Root 7 the whole square is asked. So root 7 the whole square will be root 7 into root 7. That is how much? 7. 7 is very much a rational number because it is terminating. And then what would be root 18 upon root 2? This how would you classify? Rational or irrational? Ponder over it. See, these two can be fused. At the outset you feel it is irrational, but actually this can be fused. This can be written as common square root of 18 upon 2, isn't it? So this will be root of 9, that is 3, which is rational. So square root of 18 upon square root of 2, it appears to be irrational, but actually some thought clearly shows that root 18 upon root 2 is rational. Okay with this? So we have studied real numbers. All these would be real numbers. Okay. We studied what are rational numbers, the definition, few good examples. Then we studied irrational numbers. We understood the difference between pi and 22 upon 7. So one question can come in the exam for 3 to 4 marks. Classify as rational/irrational. Okay, so it's very scoring question. So is this clear? Okay. Now before we go on to the numericals, main how to rationalize the denominator and simplify and so on, we will have to see if you are comfortable with radicals. You know, they are addition and they are subtraction. How in algebra we have 2 into x is 2x, 3 into y is 3y, then 2x plus 3x is 5x, 2x plus 3y can't be added because they are unlike terms. So something similar happens with radicals also. You have studied this in class 8, but we will have a quick revision of that first and then go on to the typical problems. Okay, few things observe and understand. 5 root 7 plus 2 root 7. This will be 7 root 7. We can add 5 plus 2 7 and root 7, 7 root 7. It is like 5x plus 2x, because if you take root 7 as x, then this root 7 also will be x, na? Same quantity. So it will be 5x plus 2x, 7x. But what is x? Root 7. So it is 7 root 7. The way you do for algebra, same for radicals here. Okay. 5 root 7 minus 2 root 7. These all things will be required when we solve actual numericals. They will come in between and trouble you. So it's better we get them clear off now only and have a crystal clear understanding of this. 5 root 7 minus 2 root 7. How much? 3 root 7. 5 root 7 minus 6 root 7. So 5 minus 6, 1. So it is 1 root 7, but it's very silly to write 1 root 7. Like we never write 1x, we write x. So that will be root 7. 5 root 7 minus root 7. Root 7 means it is 1 root 7. So 5 minus 1, 4. That will be 4 root 7. I have made a mistake. 6 root 7 it would be when there was a plus sign here. But this is 5 root 7 minus root 7. So it will be 4 root 7. Okay, because this is 1 root 7. No? So 5 minus 1, 4. 4 root 7. What is the meaning of 4 root 7? 4 into root 7. 4 root 7. 3 into root 5 into root 11. Now root 5 into root 11 will be root of 5 into 11. You can fuse the square roots when there is a multiplication or division sign. So root 5 into root 11 will be root of 55 into 3. So that becomes 3 root 55. Now 2 root 11 into 3 root 11. Root 11 into root 11 will be 11. Into 3, 33. Into 2, 66. 6 root 2 minus 8 root 2. 6 minus 8 minus 2. So it is minus 2 root 2. But if this was root 3, then we would not have been able to subtract because the radicals are not the same. However, still there is a way out. You can put the value of root 2, roughly 1.414. You could have put the value as root 3 if this was root 3 as 1.732 multiply by 8. Then 1.414 you multiply by 6. See what are the approximate answers and then subtract. So that way you can do. But in the radical form, you wouldn't be able to proceed ahead. Anyways, this was 6 root 2 minus 8 root 2, that is minus 2 root 2. Coming here, 7 root 13 upon 7. So 7 and 7 can get cut because it is 7 into root 13. So that will give you plain root 13. Now 3 plus root 5 the whole square. 3 plus root 5 the whole square. This is like what? Recall your class 8th elementary expansions, a plus b the whole square. So this is like a and this is like b. So a plus b the whole square. How we had studied? Square first term. So when you square first term you will get 9. Square second term. Second term when you square root 5 square. So root 5 into root 5, that is how much? 5. So positive 5 because whenever we square anything signs are positive. Then first term into second term into 2, that is 2ab factor. First term into second term into 2. So 3 into root 5 into 2. 3 into root 5 into 2. So that is how much? 6 root 5, positive 6 root 5. Let us simplify this. 9 plus 5, 14. 14 plus 6 root 5, which will remain as it is. This cannot be simplified further. We can't say 14 plus 6, 20, no? Because there is root 5 attached to it. और यहाँ पे root 5 नहीं है. If there was 14 root 5 plus 6 root 5, then it would be 20 root 5. But this is only 14 plus 6 root 5. So unlike radicals, so here you cannot add, it will remain like this only. It is like saying x plus 3y, it will not get added. Okay. 8 plus root 3 into 8 minus root 3. 8 plus root 3 into 8 minus root 3. This you can very well open the brackets, this with this, this with this, this with this, this with this. But if you recognize, it will save some time of yours. This is a plus b and 8 is repeating again. So again 8 can be called as a here also. Plus ka minus ho gaya. If this is b, this is also b. Both are same terms. So it is a plus b into a minus b. This is again the basics of your 7th and 8th class. A plus b into a minus b. So that will be how much? A square minus b square. So that would be 8 square minus root 3 square. 8 square is 64, root 3 square is 3, 64 minus 3 is 61. So comfortable with this? And one or two more. Root 6 into root 3 will be same as square root of 6 into 3, that is square root of 18. We can fuse the square roots when there is a in multiplication or division sign. Then root 9 upon root 3, this will be single square root of 9 by 3, that will give rise to root 3. ठीक है, but 2 tips of caution, and then we are into the problem solving. See, root of a square plus b square not equal to a plus b. If there is plus sign in between, the square root sign will not operate independently on each and every term. Same applies for minus. Root of a square minus b square not equaling a minus b. But if it is root of a square b square, then no problem. Then this can be written as root of a square into root of b square. That is ab. If it is root of a square upon b square, this will be again a by b, because the square root sign will operate independently on both the terms if there is multiplication or division, but it does not work in case of plus or minus. You can take an example and see if you wish to. See, root of 25 plus 144. If you try to take square root of 25 separately, it will be 5. If you try to operate square root sign independently on both the terms, this will be 5 plus 12, that is 17. But if I add first 144 plus 25, that is 169, and square root of 169 is 13. And our previous answer was 17. That is not correct, because it is square root of 25 plus 144. किसका square root लेना है? 25 plus 144 का. So naturally you will have to add both of them, then take the square root. Okay. However, for multiplication and division, there is no problem. There is no need to multiply and then take the square root. You can very much take the square root independently. Okay. So these things you have to keep in mind. I hope you are now clear with this, and we now start with problems. Question 1. Standard typical question. If 2 root 3 plus 5, the whole divided by 4 root 3 plus 7 is equaling m plus n root 3, find m and n. Okay. Now see, we will have to rationalize the denominator here, okay, and then equate it to m plus n root 3. It is already equal. So how do we go about? We will write 2 root 3 plus 5 upon, be very careful and observe and understand, 4 root 3 plus 7. The rationalizing factor of this, or the conjugate of this, would be 4 root 3 minus 7. This is like 4 root 3 plus 7. So to rationalize this, we will have to take 4 root 3 minus 7. Understand the bracketing sense. This plus will become minus, but this amounts to changing the question now. So to counterbalance the change, we will have to multiply up also with the same term, 4 root 3 minus 7, so that we can cancel this and come back to our original question. But do not cancel it, use it to our advantage now. So this is 4 root 3 plus 7. So we take the conjugate of it, 4 root 3 minus 7. To counterbalance the change, we multiply the numerator also with the same factor. It is like, see, if a number is 8, okay, say 8 upon 3, some fraction. If you multiply this by 4, it will change the value. So what you do, you multiply up also by 4. So it comes back to original 8 by 3. That is what we are doing. Okay, equaling m plus n root 3. This is very important because already given equal. Now look at the numerator. It is not behaving like a plus b the whole square or something, because both the quantities inside the bracket are different. So we will have to open up the brackets here. So 2 root 3 into 4 root 3. See, now the previous knowledge will come very handy here. 2 root 3 into 4 root 3. 2 into 4, 8. Root 3 into root 3, 3. 2 into 4, 8 into root 3 into root 3, that is 3. So that comes to 24. Then 2 root 3 into 7. minus 14 root 3. Signs you adjust them logically, like positive into positive is positive, positive into negative is negative. Then 5 into this, 5 into 4 root 3, that would be positive 20 root 3. Then plus 5 into minus 7, that is minus 35. Stretch the upon sign clearly and properly. Here also we can open the brackets. But if you observe, we come to a conclusion that if this is A, then this is also A, same term. This is B, this also will be B. So it becomes A plus B into A minus B. What is that? A square minus B square. So we can write this as 4 root 3 the whole square minus 7 square. This would be m plus n root 3. Okay. So this first step will fetch you 1 mark, the main step, rationalization. And then at well-defined stages, you will get another 1 mark, and to get the value of m and n correctly, another 1 mark. Okay, this we will erase now. Now time has come to simplify this. 24 minus 35, how much? Minus 11. Minus 14 root 3 plus 20 root 3. Minus 14 root 3 plus 20 root 3. That would be how much? Plus 6 root 3 divided by 4 root 3 the whole square. So it is 4 root 3 into 4 root 3. That would be how much? In case you are getting confused, I can show you here. 4 root 3 into 4 root 3. 4 into 4, 16. Root 3 into root 3, 3. 16 into 3, 48. So this will be 48. Similarly, then this is okay. 49 is equaling m plus n root 3. Very important, because it was given equal to right in the beginning. So we can't just leave it like that. Okay, this would be now minus 11 plus 6 root 3 upon minus 1. 48 minus 49 minus 1. This would be m plus n root 3. Now what to do? This negative sign will give it to the numerator. We don't keep negative signs normally in denominator, but and upon 1, so no problem. But negative sign has to be taken care. Now the numerator is a binomial. So the minus sign will be given to each and every term and not only to this 11 or 6 root 3. So when negative sign is given here, this will become 11. Plus 6 root 3 will become minus 6 root 3. Upon what? 1, because negative sign has been given. Now we are left with upon 1. So that's not a problem. This would be m plus n root 3. Now the simplifications are done. We can safely now compare. So m will be 11 now. And root 3 balances. So n, this is positive n. So root 3 balances. You can compare like that in the rough work column and see. So n, that is positive n, sign is important. N is minus 6. N will be minus 6. Root 3 will balance out each other. Comfortable? This was in the simplest form, no further simplifications and all. So this completes your simple standard 3 marks question. Question 2. If 7 plus root 5, the whole divided by 7 minus root 5 minus 7 minus root 5, the whole divided by 7 plus root 5 is equaling a plus 7 by 11 root 5 into b. Find a and b. That b is not inside the square root sign. It is a plus 7 by 11 root 5 times b. Find a and b. Okay. Here if you observe, there are two terms here. We can easily take the LCM. Because this is 7 minus root 5 and this is 7 plus root 5. So do you recollect something? It is like a minus b and a plus b. So if you take LCM, it will be easier rather than individually rationalizing them, because rationalization just changes the form. It will not change the original value, and that is what should happen. Okay, but here LCM is more convenient because of the nature of the numbers. So this is 7 minus root 5 into 7 plus root 5. See, I am not taking the rationalizing factor or the conjugate. I am simply taking the LCM. Okay, so this is already there. This 7 plus root 5 will get multiplied with the numerator. So you will get 7 plus root 5 the whole square minus this 7 plus root 5 is already here. So the 7 minus root 5 will get multiplied by the numerator. So the whole square. Why the whole square? Because 7 minus root 5 is already there. This is here. So this will get multiplied with the numerator. So 7 minus root 5 into 7 minus root 5 will naturally be 7 minus root 5 the whole square. This is done. Equal to a plus 7 upon 11 root 5 b. This will remain like this. It is very important for you to put equal to sign because they have given it already equal, and under these conditions you have to find a and b. This is now a plus b the whole square, bracket opening up. So this is 49 square first term, square second term, then first term into second term into 2. It is simple, a plus b the whole square. First term into second term into 2, that is 7 into root 5 into 2, that is positive 14 root 5, because plus into plus is plus, minus, have the bracketing sense because minus sign is applicable for the entire thing. Now this will result in 3 terms. So minus sign is valid for all the 3 terms. This is a minus b the whole square, and this minus has come here. This will be 49 plus 5, first term into second term into 2, minus 14 root 5. This is, we can open the brackets here, but why do that? I mean, we can recognize this is a minus b into a plus b. So that is a square minus b square. So that would be 7 square minus root 5. Show this step, okay, equaling a plus 7 by 11 root 5 b. Till here it is fine. These are standard 3 to 4 marks questions. Let us simplify this now. Okay, now this is 49, this is minus 49. Okay, so I'll do it little mentally now. 49 minus 49 goes away. This is plus 5. When you open the bracket, this will become minus 5. That will also nullify. Now you are left with positive 14 root 5, minus into minus plus 14 root 5. 14 root 5 is waiting here. 14 root 5 plus 14 root 5. How much? 28 root 5 divided by 49 minus 5. Root 5 the whole square is 5. This is equaling a plus 7 upon 11 Okay, now how do we go about this? This will be 28 root 5 upon 49 minus 5, how much? 44 is equaling a plus 7 upon 11 root 5b. Little interesting sum. Can we cancel this? Yes. 4 highest 4 7s are 4 11s are. Right, so this will be 7 root 5 upon 11 is equaling a plus 7 root 5 upon 11 b. Okay, now see, there is nothing for a. This is 7 root 5, this is 7 root 5 upon 11, 7 root 5 upon 11. So we can compare this, right? Now we can compare. So this will be this with this, it is matching. So 7 root 5 upon 11 is equaling positive. So I am not writing plus. If it was negative, then we would have written that. This would be 7 root 5 upon 11 b. Observe. So b will be how much? This forces b to be 1. I mean, you can take this quantity down. It's like equation. 7 root 5 upon 11 into b gives us this. So b will be how much? It's like an equation only, it's nothing new. So this will go down and they will get cancelled. So b will be 1. But then there is no a, nothing for a. Suppose if there would be like 6 or 7 or 2.5, then a could be that. In the previous sum, we could find m and n both. But here there is nothing for a. So a will be 0. Interesting, isn't it? So here a will be 0 and b would be 1. So this completes your sum, and these are very standard board style questions. They can come in your school exams and more so ever in the final class 9 exam, the paper which is going to be set by the council. So these sums are very typical and well within the scope of being asked. This completes with your question 2. Question 3. Evaluate 1 upon root 2 plus 1 plus 1 upon root 3 plus root 2 plus 1 upon 2 plus root 3. So observe now. Do not rush into solving of the sum. 3 fractions, okay. You may be tempted to take LCM. Nothing wrong. But it is going to be very tedious because see, all the terms are different. There is nothing of the type a plus b into a minus b, it's nothing of that sort. Plus there are 3 terms. Now to take their LCM is going to be very tedious. So it is not a wrong approach, but it is going to be tedious. So we think of some alternative way. What we do, we consider this expression, this term. Why don't we rationalize this here only? Because rationalization just changes the form. It does not change the intrinsic value of the term. Similarly, we rationalize this and we rationalize this also. And then we add it up because the question instructs us to add. But yes, if this was root 2 plus 1 and if this was root 2 minus 1, then we would have taken LCM because a plus b into a minus b is quickly a square minus b square and things would be quick. But here, if with all these different terms, if you take LCM, things are going to become very difficult. Plus your denominator will again come irrational after opening up the brackets. Then in the end again you will have to rationalize it. So it's going to be humongous. So we need power of observation and the correct skill so as to minimize the number of steps and arrive at our answer. So what we do now, we will do like this. Root 2 plus 1, the conjugate of this will be root 2 minus 1. To counterbalance the change, on the numerator also we do take care of the brackets. So this has been taken care of. We have just changed the form, not the intrinsic value. Plus okay, now this will be into root 3 minus root 2. Up also it will be root 3 minus root 2 plus, this is going to occupy a lot of space. You can take one term, rationalize it, take second, then third and then add. That is also okay, but here we have space, so I am doing it together. 2 plus root 3, the conjugate will be 2 minus root 3. To counterbalance the change, up also. Now this is a plus b into a minus b, that is a square minus b square. So root 2 square minus 1 square plus 1 into this will be same, no problem. This will be root 3 square a plus b into a minus b. Okay, now this is fine. We will erase the upper thing. Now root 2 square is how much? 2. 1 square is 1. 2 minus 1, 1. Oh, nice. See how simple the denominator has turned out to be. Plus root 3 minus root 2. Root 3 the whole square, 3. Root 2 the whole square, 2. 3 minus 2, 1. This is going nice. 2 minus root 3. 2 square, 4. Root 3 square is 3. 4 minus 3, 1. Now denominators are all same. So what to do? Simply add the numerators. So it will be root 2 minus 1 plus root 3 minus root 2 plus 2 minus root 3 upon 1. Okay. Root 2 minus root 2 nullify, root 3 minus root 3 nullify, minus 1 plus 2 is 1, 1 upon 1 is 1. Comfortable. So we have evaluated the expression simply, very nicely. Similar sum can be framed. Instead of giving you this plus, they can put here minus. The change appears to be simple, but many students will make mistakes. Okay, now this sum is over. I am just discussing the modification of it. This is plus, same, all terms are same, only instead of this plus, this was made minus. Then what would happen? Here you would get minus. Okay, but then when you are adding up the numerators, it would be minus 2 plus root 3. Take care of that, because the minus term is, minus sign is meant for this term. So when you are simply adding up the numerators, because the denominators are the same, it will be root 2 minus 1 plus root 3 minus root 2 minus 2 plus root 3, the whole divided by 1, and accordingly the answer would change. So if there would have been a minus sign here, it would have been a better sum. Anyway, I have drawn your attention towards that fact and what mistake you can make. So now this completes, anyway, this is original now plus. This completes with your question 3. Question 4. Find the values of a and b if 2 root 3 plus 3 root 2 the whole divided by 2 root 3 minus 3 root 2 equaling a plus b root 6. These two things are already given equal. Under the given conditions, we would like to find the values of a and b. Let's see how do we go about this. See, this is 2 root 3 plus 3 root 2. I am copying the question. 2 upon 2 root 3 minus 3 root 2. So here we will rationalize the denominator. Okay. Now if we rationalize the denominator, what would be the conjugate of this, or the rationalizing factor? 2 root 3 plus 3 root 2. We are rationalizing the denominator in this case. So this was 2 root 3 minus 3 root 2. So the RF factor would be, rationalizing factor RF, 2 root 3 plus 3 root 2. But to counterbalance the change, same term has to be repeated at the top. have the bracket sense? The whole thing gets multiplied, is equaling a plus b root 6. Okay, we can open the brackets of the numerator, but hold on, use power of observation. 2 root 3 plus 3 root 2 into 2 root 3 plus 3 root 2. Aren't both the terms the same? So it is like a plus b into a plus b. That is a plus b the whole square. That would be little quick. So this will be 2 root 3. But if such numbers are not synchronized, then you will have to open the brackets of the numerator the way we did in our previous sums. So 2 root 3 plus 3 root 2 the whole square divided by, this is a minus b into a plus b, because see, both the terms are same, 2 root 3, 2 root 3. So if this is a, this also will be a. This is 3 root 2, this is 3 root 2. This is b, this also will be b. So it is a minus b into a plus b. So this will be 2 root 3 square, the whole square, minus 3 root 2 the whole square, because a minus b into a plus b is what? A square minus b square. This is equaling a plus b root 6. This is a plus b the whole square. So now we can go fast because you have sum number 4, you are comfortable now. So this will be a square. So 2 root 3 the whole square, that is 2 root 3 into 2 root 3. How much? 2 into 2, 4, root 3 into root 3, 3. 4 into 3, 12. 12 plus 18. Whenever we square, terms are always positive. Then first term into second term into 2. So 2 root 3 into 3 root 2 into 2. You can do in the rough work column and see if you are not able to do it mentally. No problem. 2 root 3 into 3 root 2 into 2. So 2 into 3, 6, 12. That would be plus 12 root 6 divided by, this would be 12 minus 18. Do not forget to write equaling a plus b root 6, because that was given right in the question. 12 plus 18, 30. 30 plus 12 root 6. The whole divided by minus 6 is equaling a plus b root 6. Can we add 30 and 12 root 6? No, there is a radical here, there is no radical here, no? So we can't add like that. Now see, from the numerator we can remove something common, or we can do double division. Like this is 30 plus 12 root 6, the whole divided by minus 6. So we can give this term here because it will get nullified. We can give this minus 6 to this term also. It is like, see, x plus y, the whole upon z can be written as x upon z plus y upon z, no problem. But if there was x into y upon z, then z cannot be given to both. Then z will have to be given to one of the two terms. But if it is plus or minus, and if it is full divided by z, then z can be given to both the terms. Okay, so this would be 30 upon minus 6 plus 12 root 6 upon minus 6 is equaling a plus b root 6. Comfortable till here? Now simplify. 30 upon minus 6 minus 5, 12 root 6 upon minus 6. So 12 upon 6, this minus sign will be given to the numerator. So that would become minus 2 root 6 is equaling a plus b root 6. Now a will be minus 5. Now compare, all the simplifications are done. Now compare this. This is positive b root 6 is equaling what now? Minus 2 root 6. Take care of the signs here. Most of the students make mistake in signs. Now we want to find b, na? Okay. So b would be minus 2 root 6 upon root 6. How much is that? Minus 2. So b would be minus 2. You could have done this by observation also, but if you find that difficult, actually show these steps, no problem. So just double underline this. B is minus 2 and a is minus 5. Now this completes with your question number 4. Question 5. If y is equaling root 11 minus 2 root 3, find the values of y square minus 1 upon y square, second y plus 1 upon y the whole cube. Let us see how do we tackle this. Yes, at the outset it appears it is only direct substitution, but we have to substitute very tactfully, else it will become very humongous to simplify. So let's take first subpart. We wish to find the value of y square minus 1 upon y square. Okay. So what we will do, now see, y square is not a problem because y is given and this is a simple binomial, we will square it up. But 1 upon y square will create a problem because it will be 1 upon root 11 minus 2 root 3 the whole square. It will give rise to so many terms. Then you will take LCM and all that. Still the denominator will remain irrational. So this would be a little difficult approach. So what we use a small trick here. This will be y square minus, like this we write it. This would be better. See, we have not changed any value. This was y square minus 1 upon y square ka value find karna hai. We just write it in a little different form. This will be y square minus 1 upon y the whole square. So 1 square is 1 and y square is y square. So 1 upon y the whole square, 1 upon y the whole square is same as 1 upon y square. But by doing this, simplification will become a lot more easy. Okay. And this is y square. So that is y is root 11 minus 2 root 3 the whole square minus 1 upon y. Y is what? Root 11 minus 2 root 3. 1 upon y. Y we have substituted. The whole square. Instead of doing 1 upon y square, we are doing 1 upon y the whole square. Okay. This we will open up the brackets, a minus b the whole square. So square first term, square second term. So this will be 12. Sign will be positive. Then first term into second term into 2. Sign to be adjusted logically. So this will be root 11 into root 3, root 33 into 2. Okay, how much? That is 2 root 33 into 2 is first term into second term into 2. So that would be now minus 4 root 33. Okay, minus 4 root 33. Any wrong? Nah. Okay, this is fine. Now here we will rationalize it inside only. Why square it unnecessarily? Let's first rationalize. The square is waiting outside to operate. Let it operate after some time. अंदर का अंदर हम इसको rationalize कर देंगे and then we will square. So simply the term becomes smaller and compact. So root 11 minus 2 root 3. This you rationalize. It will be root 11 plus 2 root 3. Okay with this? Up also root 11 plus 2 root 3 to counterbalance the change, and do not forget to put this square that comes as it is. And leave 1 or 2 lines at least while writing all this, otherwise it will become too cluttered and you yourself will get confused. This also we will erase now. So have you realized the small trick which we have used to make things little easy? Okay. Now this we can simplify. 11 plus 12, that is 23, minus 4 root 33 minus, this will be root 11 plus 2 root 3 upon, this is a minus b into a plus b. So this will be a square minus b square. So I am doing that mentally. So a square will be like 11 and b minus b square. So 2 root 3 the whole square. So that is 12. Okay. Do not forget to put this power 2. Now this will be 23 minus 4 root 33 minus root 11 plus 2 root 3. 11 minus 12, how much? Minus 1. The whole square. Many times people simplify the inside stuff and they forget to put that original power 2. Okay. Okay, so this will be 23 minus 4 root 33. Okay, now this minus we will give it to the numerator. See, we cannot do minus into minus plus because there is a square which is waiting first to be operated and then this minus sign will operate. So you just cannot pull this minus sign from this bracket and give it here. So this will give it here. So it will become minus root 11 minus 2 root 3 upon 1. So that's not a problem, but the minus sign will be given to the numerator and square. This will keep coming down as it is. Okay. Now this is like a minus b the whole square, binomial square. So square first term. So this will become 11. Minus root 11 into minus root 11. That will become positive 11. Whenever we square, terms are positive. This will become plus 2 root 3, 4, 12. This is 12. Then first term into second term into 2. So that would be 4 root 33 and negative into negative is positive. So that is plus 4 root 33. Now the square will come? No, because the square has already operated on this and it has resulted in this expression. This minus has come down here. Now what remains is to only open up the brackets. So it is 23 and we'll put it there. Now this will be 23 minus 4 root 33 minus 11 minus 12 minus 4 root 33. Okay, what gets cancelled now? Let's see. 23, let's take the terms without the radicals first. 23 minus 11, how much? 12. 12 minus 12, 0, gone. Minus 4 root 33, minus 4 root 33. That is minus 8 root 33, isn't it? There is minus x is minus 2x. So minus 4 root 33 minus 4 root 33 is minus 8 root 33. And that is our small answer. Did you like this sum? Okay. Subpart 2 is remaining. Now once you have understood this, then subpart 2 will be fairly simple. So this completes your answer for subpart 1. Now we are left with only y plus 1 upon y the whole cube. Let us see how do we tackle that. Okay. Now see, here you need not do a plus b the whole cube. Yes, you are aware of this formula and it is very much there in standard 9. But a plus b the whole cube, when you open it up, it becomes quite big. And here the y itself is like a binomial. So if you are going to open it up, that simplification is too much. So what we will do, let us see. We will write like this: y plus 1 upon y the whole cube. do not make the mistake of writing this as y cube plus 1 upon y cube. A plus b, the whole cube is not a cube plus b cube, it is much more than that. So this will be root 11 minus 2 root 3 plus 1 upon, it is not full upon, okay, it is only 1 upon y. 1 upon this, the whole cube. Now this I am erasing, okay. This is the whole cube. Now what to do? You rationalize it here itself, and this is so simple, binomial. You rationalize this and simplify and then take the whole cube. Getting it? So this will be root 11 minus 2 root 3 plus this is root 11 plus 2 root 3. We rationalize this. To counterbalance, we put it here also. The same thing. Do not forget to put the whole cube. These sums are not very difficult. Twice if you practice it, you will get a good hang of it. Okay, but if you would have taken LCM and simplified and then cubed it, it would be very cumbersome. This will be root 11 minus 2 root 3 plus 1 into this, not a problem. Root 11 plus 2 root 3 upon, this is a minus b into a plus b. So that is a square minus b square. So that would be 11 minus 12. Okay. Do not forget to put this whole cube, as the cube has not yet operated. We are just simplifying andar ka masala only. So root 11 minus 2 root 3 plus root 11 plus 2 root 3. 11 minus 12 is minus 1. The whole cube. Now this will be root 11 minus 2 root 3. This sign you will have to give it to the numerator. Okay. If there was, okay, first let me deal with this. This would be now minus root 11 minus 2 root 3. The whole cube. So what gets cancelled now? Oh, this gets cancelled, nice. Minus 2 root 3 minus 2 root 3 will be how much? Minus 2 root 3 minus 2 root 3 would be minus 4 root 3, the whole cube. So now this we'll have to multiply, see. Minus 4 root 3, I am not taking the sign we will adjust later on. 3 times. 4 into 4, 16, 16 into 4, 64, root 3 into root 3, 3 and again root 3. That comes to 12, 192. So 192, 12, yeah, 192 root 3 with a negative sign. Isn't it? Because minus into minus is minus. So this is minus 192 root 3 and we are done with the sum. A word of caution, suppose if this was minus sign, suppose, now I am discussing a different situation, this sum is over, you have understood this. Suppose if this was a minus sign, then it is meant for the full term and there is one more minus here. So minus into minus will become plus, then it will be plus root 11, so then this you will copy it down, then it will be plus root 11 plus 2 root 3 and then the whole cube. You know, if it was like that, because this can work like this, you know, because the cube is waiting outside. Cube is not meant for this, it is meant for the full thing. So inside we are free to simplify. But anyway, this was plus, so accordingly we adjusted it. And this completes with your question number 5. By this time, if you work out these kind of questions with carefully designed numbers, you know, you will get a good grip on this topic. Okay, now to conclude we need to know what is a surd. Sometimes it can be asked, classify whether the following are surds or not. So what's a surd? See, if nth root of x results in an irrational number, if nth root of x results in if the answer results in an irrational number and n is a positive integer, that is also there, and x is a positive rational number. If all these three things are satisfied, then nth root of x is known as a surd. I repeat, nth root of x if the answer is irrational and n happens to be positive integer and x happens to be a positive rational number, then under such conditions, three conditions have to be satisfied. The answer has to be irrational, n has to be a positive integer, and x has to be a positive rational number. If all these three conditions are satisfied, then nth root of x is known as a surd. Okay, so let us see which of the following are surds. So we have put like 4, 1, 2, 3, 4. Which of them are surds and which of them are not? Cube root of minus 125. Cube root of minus 125. Will it be a surd? No, because the x has to be positive rational number. Now this is not positive, so the one condition is violated here only. So this is not a surd. Then square root of 3 plus root 2. Now look at 3 plus root 2. Root 2 is irrational, we know that. If I add 3 to it, that answer also will be irrational. So 3 plus root 2, this body is irrational. And look at the conditions. This is a first condition, this is a second condition, and this is a third condition. Any one of the condition is violated, it is not a surd. 3 plus root 2 is what? Irrational. Here x has to be rational, but this body quantity is irrational because root 2 is irrational. If I add 3 to it, that also will be irrational. So it violates this condition. Gone. So this is not a surd. Now cube root of 25 into cube root of 40. What to do? You may feel something, but it may turn out to be something else. Now see, this can be simplified as cube root of 25 into 40. The way two square roots can be fused if there is multiplication sign, the cube roots also can be fused. So this will be cube root of 25 into 4 is 100. Okay. Cube root of 1000. Cube root of 1000 turns out to be 10. So this is not a surd. Which condition it violates? See, this 3 is a positive integer. Okay. Here the quantity sitting here should be a rational number, positive rational number. This is positive rational number. So why it is not a surd? There is one more condition. The answer should be equal to irrational. The answer should be irrational, but we are getting the answer as 10. 10 is rational number. So this violates condition number 1. So this is not a surd. Finally, root 7. Root 7 means there is a hidden 2 out here, second root of 7, which we never write. So this is 2 out here. Okay, this quantity is actually 2, it is hidden, we never write that. N, this is positive integer, yeah, this is 2, so it is positive integer. Okay. 7, this body, this term should be a rational number, positive rational number. Yes, 7 is a positive rational number, it is terminating. So will it be a surd? Look, equal to irrational. The answer should be irrational. Root of 7, yes, irrational. If I do root of 7, I mean it will not be a rational number. We know all square roots are irrational numbers except the square root of perfect squares. So this answer will result in irrational number. So it satisfies condition number 1. So this is a surd as it satisfies all the 3 conditions laid down in the definition of a surd. So this will be a surd. Fine. So you can have questions in the exam, classify into rational, irrational. Check if the given out of the following terms, which of them are surds and which are not. So such questions can come. Fine. So this completes with your topic of rational and irrational numbers. Thank you so much. Hope you enjoyed it.